Alright, here we go. Video 6.1, Balancing Equations, FLM, FLM, and the mole. There we go. Alright, let's talk a little bit about balancing equations. If you remember, that's what we left off with last semester. So in balancing equations, you were given an equation. Remember, we have the left side of the arrow that's called the reactants, and the right side of the arrow is called the products. And we have to have all the elements on the reactant side match up with all the elements on the product side, both in what element they are and in number. So remember, we made a lovely chart when we did this. And let me get my pen up. We made a lovely chart. And on each side of the chart, we listed our elements. We have aluminum, we have carbon, and we have oxygen. And the same thing on the product side, we have aluminum, carbon, and oxygen. And what we wanted to do is we wanted to list the number of each one we had. So aluminum, we look right up here and we have 2 aluminums. For carbon, it's inside the parentheses. Remember, there's a coefficient here that's 1. And then if there's a number outside the parentheses, it multiplies in. So 3 times 1 is 3. Same thing with the oxygen. We have 3 times 3, which is 9. Let's go to the product side. We got 2 aluminums here. We have 1 carbon. Now for oxygen, hopefully you remember this. We have 3 oxygens here, but we also have 2 here. Remember, there's plus signs in there, so we're just going to add those up. So we're going to have a total of 5. All right. Let's see if they're balanced. So aluminum's good, but carbon's not good, and neither is oxygen. If you remember, there's now only one thing we can change, and that's these big numbers in front, the coefficients. So we're going to put coefficients here. When we put a number in front, that is going to multiply times the subscripts here. So we have 3 carbons on this side, we only have 1 over here, so we need to put a 3 in front of this. That's a 3. It's a horrible 3, I know, but it's a 3 nonetheless. We have 3 times 1, which is now 3 carbons. But don't forget about these oxygens. We have 3 times 2, which is 6, plus 3 more, which is a total of 9. So 3 times 2 is 6, plus we have 3 more, which is a total of 9. And we look at this, 2 aluminums, 3 carbons, 9 oxygens. We now have a balanced equation. So all we needed to do is put a 3 here. Now, I left these coefficients blank, but if you remember, if there's a blank here, it really means we have a 1 and a 1. Okay? So that's balancing equations. Let's do another one. List your elements. I've got potassium and bromine and chlorine. Same thing on the product side. We have 1 potassium, 1 bromine, 2 chlorines, 1 potassium, 2 bromines, 1 chlorine over here. Potassium's good, but bromine is not. So we're going to put a 2 in front of here. 2 times 1, don't forget it's got to go for both elements. So 2 times the coefficient 1 is 2. 2 times 1 is 2. Okay, but potassiums aren't good, but that's okay. Let's put a 2 in front of here. 2 times 1 is 2. 2 times 1 is 2. And let's check them all. Potassium's good. Bromine's good. Chlorine's good. And we now have a balanced equations with our coefficients that are 2. There's a 1 here, 2, and a 1. All right. FLM. This stands for factor, label, method, also known as dimensional analysis if you look at other books sometimes, or when you go to physics. Factor, label, method. We did this at the beginning of the semester. Now we're reintroducing it. All right, factor, label, method is how we convert. We're going to start easy with stuff you might know off the top of your head, but I'm going to show you how to put it into a problem, because you always have to show work on these. Always, always, always. You have to show work. So let's look at this question. If you have $7, how many quarters would you have? Okay, $7 bills, you want to do it in quarters, how many would you have? All right, in factor label method, we go back through this, if you remember, you're going to do this little cross here. That's our phlegm charts. Okay? We always put what you start with here, or what you're given. Okay? And then what we're going to do over here, okay, this is going to be your conversion factor. Alright, this is your conversion factor. This is how you convert. Okay? So your unit with what you started with is going to be the same unit. Okay? And then what you want to get to. So this is what you want to get to. Alright? The unit that you start with. Alright? This will all be, oh, that says ghetto there, doesn't it? That's get to, not ghetto. Alright? So, let's do this problem here. Okay. Here is our lovely phlegm chart. Alright, what do we start with? We start with $7. So I'm going to put 7. Oops. Let's try to write again. There we go. Dollars. Alright, now, what I want to do is I want to go from dollars to quarters. Alright, so when we do a phlegm chart, we're not going to put any numbers yet, we're going to put units. Alright, what it goes down here is the unit that we start with. We started with dollars, so I'm going to put dollars down here. Alright, what do I want to get to? Well, I can go from dollars to quarters in one step, because I know this conversion factor. Right? And a conversion factor is, well, how many dollars are equal to how many quarters? Well, we know that $1 is equal to 4 quarters. $1 is equal to 4 quarters. Okay, so this right here is called our conversion factor. Our conversion factor is $1 to 4 quarters. Now, why is dollars on bottom? Because with this awesome thing here, it's all about canceling out units. If we have a unit on top of the phlegm chart and the same unit on the bottom of the phlegm chart, these units will cancel out. Alright? Now, there's only one unit left up here, quarters, and that's a good thing. How many quarters would you have? Alright, last thing mathematically, if it's on top, we're going to multiply, and if it's on bottom, we are going to divide. So this is easy enough anyways. Alright, so on top we're going to multiply 7 times 4. 7 times 4, when you plug into your calculator or do it in your head, 7 times 4 is 28. And then we're going to divide by 1, which is still 28. So our answer is 28. Now it's really important you use your units here. And our unit ends up in quarters. Okay, so this is 28 quarters. There's the answer to our question. Let's go to this next one. All right. If you need 45 eggs, how many dozen eggs do you need? Well, when you go to the store and you buy eggs, eggs come in dozens. So, first thing we need to do is set up our phlegm charts. Remember, what you start with goes here. What do we start with, or what are we given? We're given 45 eggs. So 45 eggs goes here. Alright, now, no numbers yet, just units first. I know I want to get rid of eggs, and I want to go to how many dozens of eggs. Now, maybe you know this off the top of your head, maybe you don't. What the heck's a dozen? Well, if you don't know, 12 is equal to 1 dozen. So, that means when you buy a dozen eggs, 12 eggs come in a thing that's for 1 dozen. So, our conversion factor here is 12 eggs equals 1 dozen. These are equal to each other. If you get 12 eggs, you get 1 dozen. So in this one, we're going to multiply on top and divide on bottom. 45 times 1 is 45. and then divided by 12. So get your calculator out. You got 45 divided by 12, and you press enter. And your answer comes out to be 3.75. Now, what's our unit? And it is important that you put the units. That's a decimal there. It's a really bad decimal, but it's decimal. Eggs have canceled out, right? Top and bottom, they cancel. We're left with dozens of eggs. Now, you can't go to the store and buy 3.75 dozen eggs, okay? So if you were actually going to buy these, okay, how many dozen would you get? Well, you would have to get 4 dozen, and you would have a few eggs left over, okay? All right, with all that being said, we've reviewed balancing. We've done a phlegm chart, 2 of them. Now let's talk about this thing called moles. All right. In science, we use this thing called moles. All right. You use words to represent large numbers. If you have a pair of shoes, how many shoes do you have? Well, you've got 2. We just talked about dozen. If you have a dozen eggs, you have 12 of them. So there's these words we use to describe a certain number. Well, if I pick up this lid here and I say how many atoms are in this lid, well, atoms are super, 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 super tiny. And they're so tiny that if I was to count these atoms, I couldn't have, in my lifetime, if I started now and tried to count all of these, if I could see them, I wouldn't finish. Okay? There are billions and 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 billions, I don't think I said it enough, but billions of atoms in here because they're so small. And so scientists needed a word, all right, to describe a whole bunch of atoms. Okay? Because, as you see here in the question, how many atoms of copper are in a penny, or how many molecules of water are in a cup of water, or how many formula units of NaCl, sodium chloride, are in a grain of salt. There are billions and billions and billions of these. And so what we did as scientists is we came up with this term called the mole. Okay? No, not the thing that digs underground. Okay? But a mole is kind of like dozen and pair. It's a term that's used to describe a really, really big number. And that number is this. 1 mole is equal to 6.022. Hold on one second. Yes.
Sorry.
No, it's okay.
I have a quick question.
Go ahead.
For you. Do you mind if somewhere on your seats I have a small little sticker with a number on it?
Don't bother me at all.
Moving to a new management system
Nope.
because my class is getting bigger. Can I come label them sometime this afternoon?
Yeah.
Okay.
No worries.
I'll try to keep it off the actual desk so that...
You can put it on the desk. You can put it wherever it's best. I don't want my kids to mess with them, but yeah, wherever you need. No worries. Now, 1 mole is equal to 6.022 times 10 to the 23rd. That's a huge number, and yes, we just use scientific notation. I just give you a heads up, sometimes people use 6.02 times 10 to the 23rd. And if you want to use that, I'm perfectly fine with that. All right? Pretty much the same number, it's just going one more decimal place. I really don't care which one you use, but just know when you get an answer, it might be slightly different depending on which number you use. All right, so 1 mole is equal to that. If you want to know how many that is, I'm going to go down here because I've got a little room. All right? To write this out in standard, 6.022 times 10 to the 23rd, there's 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Down at the bottom there, that is how big the number is. Okay? Why is the number so big? Because remember, atoms are really, 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 really tiny. So you have to have a whole bunch of atoms to make up something like this lid, or the number of atoms in a penny, or even the molecules, the number of molecules in a cup of water. Okay? So, just like 12 is equal to...
Savage, can you please report to the media center? Thank you.
Oh, announcement. Just like 12 is equal to 1 dozen, 1 mole is equal to 6.022 times 10 to the 23rd. So, how many hammers are in a mole of hammers? Okay, a mole of hammers. If I have 1 mole of hammers, for every 1 mole of hammers, I have 6.022 times 10 to the 23rd hammers. Right? So moles of hammers cancels out. So how many hammers do I have? I have 6.022 times 10 to the 23rd hammers. How many M&Ms are in a mole of M&Ms? Well, once again, for every 1 mole, I would have 6.022 times 10 to the 23rd M&Ms. How many carbon atoms would be in a mole of carbon atoms? Well, if I had 1 mole of carbon atoms, I would have 6.022 times 10 to the 23rd. Oh, that's a horrible R. Carbon atoms. Alright, so notice here. You can have a mole of hammer, a mole of M&Ms, a mole of carbon atoms. It doesn't matter. Alright, if you have 1 mole of it, it's going to be the same number. 6.022 times 10 to the 23rd. Okay? So, remember, the mole is the term we use, right, in science to be able to count a whole bunch of atoms, right, because they're really, 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 really tiny. This number is really important, okay? And this number, 6.022 times 10 to the 23rd, is known as Avogadro's number. All right? This is known as Avogadro. It's actually named after the scientist who helped figure out all of the amount of atoms, all right, that are inside, and molecules and formulants that are inside of different particles. Okay, so they named it after him. It's called Avogadro's number. Okay, so this is known as Avogadro's number. Make sure you write that down. Okay, make sure you go back to this video if you need some help on any of this. Pause, rewind, fast forward, whatever you need to do to know this stuff. All right, bye.